Now I'd like to discuss how to find the inverse of a matrix. If you have the technology available, I highly advise going in and using it. Let's edit matrix A, make it a 3 by 3 matrix, and enter the numbers into there. -2, 4, -6, 2, 1, 0, 4, -2, and 5. Now we can go back to the main screen, second quit, there it is, and then say matrix A, and then just hit the inverse button, which I think is that one. Yeah, A to the -1, enter, and there's our inverse matrix. There is also some free software online that would allow you to type in the matrix and get the inverse. And you can see these two outputs give us the same thing. They look a little bit different. This one has already multiplied through by the 1/2. This one you have to still do that. So 10 divided by 2 is 5. -14 divided by 2 is -7, etc. But I'd like to also discuss how to do this manually, which will take up most of the rest of the time of this video. It turns out there is a general method for finding an inverse matrix. You take the transpose of the cofactor matrix divided by the determinant. Now, it doesn't take that long to say. Take the transpose of the cofactor matrix divided by the determinant. However, it does take a long time to do. And secondly, we need 3 fairly difficult to answer questions before we can approach this. What is a transpose? What is a cofactor matrix? And what is a determinant? Now, determinant shows up in your list of matrix functions right here as operation number 1. So if I go matrix math determinant of our matrix, which was matrix A, it gives me -2 for the answer. If I wanted to calculate the determinant manually, there are 6 different ways, I think, to find the determinant of a 3 by 3 matrix. The 6 different ways involve expanding the matrix along this row, this row, this row, or along this column, or this column. Finding the determinant is going to involve this sign matrix, which I'll introduce now, and I don't know if there's a name for this sign matrix, but it always starts with a plus in the upper left-hand corner and alternates negative and positive all the way down. So I'm going to start finding the determinant in the first way, expanding along this row. I'm going to take this number times a function of these numbers here, plus this number times a function of these numbers here, plus this number times a function of these numbers here. And I left something out. It should have been this number times these numbers here times +1, plus this number times these numbers here times -1, plus this number times these numbers here times +1. More specifically, I didn't tell you what I was going to do with these two numbers. What I'm going to do is take 1 times 5 minus 0 times -2, which is 5. And then with these two numbers, I'm going to take 2 times 5 minus 0 times 4, which is 10. And with these 4 numbers, I'm going to take 2 times -2 is -4 minus 4 is 0. 2 times -2 is -4 minus 4 is -8. That was a mistake I made. I'm going to continue on the problem. I'm going to multiply this -2 times 5 times +1 to get -10. And then I'm going to take the 4 times the 10 times -1 to get -40. And then I'll take -6 times -8 times +1 to get +48. Adding these together, I get negative 50 plus 48, which is negative 2. And this matches what we got on the calculator, so that's a good sign. I'm going to move that aside and try a different column for expanding our determinant. Negative 6, and we're going to look at this minor. 2 times negative 2 minus 4 would be negative 8. That's already there. Now we'll look at these four numbers, negative 2 and 4, 4 and negative 2. 4 times 4 is 16 minus, wait, well, it comes out that way. Negative 2 times 1 minus 4 times 2 is negative 10. And then we'll take negative 6 times negative 8 is 40 times positive 1 is 48. Minus 0 times negative 8 is plus 0. And plus 5 times negative 10 is minus 50. That also gives us negative 2. So it doesn't matter which of the rows or columns we use, it always comes out to be the same value for the determinant. Now we've been building up this secondary matrix down here based on that 5 came from those four numbers there, and the negative 8 came from those four numbers there. These numbers are actually called the minors. What happens is this is called M11, M12, M13, and the minors are the determinant of the matrix that remains without that row and column. For instance, if I have the minor from, or the minor in row 2, column 1, I'm going to cancel out row 2 and column 1 and use whatever's left to get the minor. 4 times 5 minus negative 6 times negative 2 is 8. And then continue on in that fashion to get the other minors. Now we've discussed what is a determinant and what is the cofactor matrix. Well, we've discussed what is a determinant. We haven't discussed what is a cofactor matrix or what is a transpose. Turns out that the determinant or the cofactors can be found easily from the minor matrix simply by taking that sign matrix, all of those negative signs there, and multiply through the basically make these numbers the opposite sign. So change the positive 10 to negative 10, the negative 8 to positive 8, the 12 to negative 12, and the 8 to negative 8. And that gives us what's called the cofactor matrix. The last thing we want to do, we're very close to the solution at this point because we have the cofactor matrix, we have the determinant, and all I have to do is tell you what the transpose of the cofactor matrix is. And that is just to take these rows and turn them into columns. So that row 5, negative 10, negative 8 becomes the column 5, negative 10, negative 8. This row negative 8, 14, positive 8 becomes the column negative 8, 14, positive 8. This row 6, negative 12, negative 10 becomes the column 6, negative 12, negative 10. And we're going to take all of that and divide by negative 2 and get pretty much the same thing that the technology gave us. Negative 5, notice these signs are opposite because this is negative 2, this is positive 2. 5, negative 5, negative 8, 8, 6, negative 6, 10, negative 10, 14, negative 14, negative 12, 12, negative 8, 8. Well, apparently I made one mistake somewhere. Let's see if we can locate it. It was most likely when I was calculating this minor here, which is based on these four numbers. Whoops, not so fast. I was calculating this number, which, remember, I transposed it, so it actually has to do with the minor from this one, which involves these four numbers. -2 times -2 is 4, minus 4 times 4 is 16, so 4 minus 16 would be not -8, but -12. And when I took the negative sign of that, that would have given it a positive 12 when I took the cofactors, and I'd have positive 12 down here, which does match. Well, after I multiply that by the -2, it matches the sign it should have. So there you have it, the transpose of the cofactor matrix divided by the determinant. That is what the inverse is. And may you always have a calculator available so that you don't have to do it by hand.